Hello, in this video we are going to graph f of x is equal to x squared plus 6x plus 3. The first thing we need to decide is whether the parabola opens up or down. Since x squared is positive, the parabola opens up. The second thing we need to do is to find the vertex. And in order to do so, we need to find axis of symmetry first. And it's happening at x is equal to negative b out of 2a. So let's calculate x is equal to negative b divided by 2a. In this function, b is 6 and a is 1. So x is equal to negative 6 divided by 2 times 1 is 2. So x is equal to negative 6 divided by 2 is negative 3. So when x is equal to negative 3, we have a vertex. So right now we only have x value of the point for the vertex, which is negative 3. And we still need to calculate the y value. And in order to do so, we need to calculate f of negative 3. By plugging it into the x squared plus 6x plus 3, and we substitute negative 3 instead of x. So we have f of negative 3 is equal to negative 3 squared plus 6 times negative 3 plus 3. So we get negative 3 squared is negative 3 times negative 3 is positive 9. Plus 6 times negative 3 positive times negative gives us minus. 6 times 3 is 18 plus 3. This gives us f of negative 3 is equal to 9 minus 18 gives us negative 9 plus 3. So f of negative 3 is equal to negative 9 plus 3 is negative 6. So y value of the vertex is negative 6. So the point of the vertex is negative 3, negative 6. The vertex is the most important part of the parabola. So the next thing we need to calculate is the intercepts. So let's do x-intercepts first. X squared plus 6x plus 3 cannot be easily factored. So let's use quadratic formula of x is equal to negative b plus or minus square root of b squared minus 4ac out of 2a. And in this function, a is equal to the coefficient of x squared is 1, b is equal to coefficient of x is 6, and c is equal to the constant number is 3. So let's plug this into the formula. We have x is equal to negative b, and b is 6 plus or minus square root of b to the second. b is 6 minus 4 times a times c. a is 1, c is 3 out of 2 times a, and a is 1. So we get x is equal to negative of 6 gives us negative 6 plus or minus square root of 6 to the second is 36 minus 4 times 1 times 3 is 12. So 36 minus 12 out of 2 times 1 is 2. This gives us x is equal to negative 6 plus or minus square root of 36 minus 12 is 24. So square root of 24 out of 2. So now we need to calculate the x values. The first x value is negative 6 minus square root of 24 out of 2, and the x2 is negative 6 plus square root of 24 out of 2. We put the numerator in parentheses because it has a plus or a minus in there. So we get, open a parentheses, negative 6 minus square root of 24, close the parentheses, divided by 2. This is equal to negative 5.449489.743. So let's round this to one decimal place and we will get the first x value. X1 is about negative 5.5. We just need one decimal place to know where to place this on the x-axis because x-intercepts are happening when y is 0. So first x-intercept is negative 5.5, 0. The second x-intercept is exactly the same, except we have a plus instead of minus, so it's negative 6 plus square root of 24 out of 2, and it's equal to negative 0.5505102572. So if you round this off to one decimal place, it's negative 0.6. So x2 is negative 0.6 and the second x-intercept as a point is negative 0.6, 0. The next thing we need to calculate is y-intercept. Y-intercept happens when x is equal to 0. So we need to calculate f of 0 by plugging it into the original equation of x squared plus 6x plus 3. So let's plug 0 instead of x and we get f of 0 is equal to 0 squared, which is just 0, plus 6 times 0, which is just 0, plus 3. So f of 0 is equal to 0 plus 0 plus 3, 3. So if f of 0 equals to 3, so y value is equal to 3. So our y-intercept is 0 for x and 3 for y. Once we have vertex and intercepts, we can begin graphing the parabola. It has axis of symmetry at negative 3 and at negative 3, negative 6, we have a vertex. At vertex you can either have the maximum or the minimum of the graph. Then we have x-intercepts at negative 5.5, which is between negative 5 and negative 6, and the other one is at negative 0.6. So between 0 and 1 we have the second x-intercept. So negative 5.50 is our smallest x-intercept, and at x equals to negative 0.60 is our larger x-intercept, and at 0.3 we have y-intercept. Now this point is 3 units away from the axis of symmetry, so I know 3 units into the other direction we have a mirror point for the y-intercept because the graph is symmetric across the axis of symmetry, and this point is at negative 6, 3. Since I want to know how it opens up near the vertex, I'm going to choose one x value next to it. So we have vertex at negative 3. I'm going to plug in x equals to negative 2 to see what's happening to y and calculate f of negative 2, which is negative 2 to the second plus 6 times negative 2 plus 3, and you can just plug it into the calculator. So you can enter negative 2 to the second plus 6 times negative 2 plus 3 into a scientific calculator and you will get negative 5. So when x is negative 2, y is negative 5. So at negative 2, negative 5, we will have a point, and we will also have a mirror point at x equals to negative 4 because the graph is symmetric across the axis of symmetry. And now we just draw the graph through the points. And this is our solution. That's all.